Physical Science Exam 2015, question 23. Limestone is a rock that is composed mainly of calcium carbonate. A scientist wishes to determine the percentage by mass of calcium carbonate in a sample of limestone. To do this, a 0.280 gram sample of the limestone is reacted with hydrochloric acid. This required 44.6 millilitres of 0.102 moles per litre of hydrochloric acid to react completely. Assume any impurities in the sample do not react with the hydrochloric acid. So we have this chemical reaction for the chemical equation for the reaction is here. Calculate the number of moles of hydrochloric acid used in the reaction. Right. Let's have a little look. We have got here. So the concentration is equal to the number of moles divided by the volume. If that's going to be the case, then rearranging that, we get N is equal to C times V. Now, so the concentration of the hydrochloric acid, I'm not looking for the number of moles of hydrochloric acid first of all. HCl equals 0.102 multiplied by, and we want to have that in litres, so that's going to convert that into litres. So that'll be 0.0446. Zero four four six multiplied by 0.102. That's right. Equals 0.00455 moles of HCl or hydrochloric acid. How many moles of calcium carbonate are there in the rock sample? Well, in this case, for every mole of calcium carbonate, you're going to need 2 moles of hydrochloric acid. So the number of moles of calcium carbonate is going to be divided by 2. Is that number divided by 2? Because you use that many moles to go with half that many. So N of CaCO3 equals 0.00455 divided by 2 equals 0.00227 moles. Or if you prefer, 123 equals 2.27 by 10 to the minus 3 moles. Calculate the percentage of calcium carbonate in the rock sample. Okay, well, if we know we've got this many moles of calcium carbonate, do we know what the... We're not given the molecular mass of calcium carbonate, so we'll have to work that out. Coming back once again to our information sheet. Number of moles is equal to mass divided by the molecular mass. N equals the mass over the molecular mass. So therefore, the mass equals N times M, which equals 2.27 times 10 to the minus 3 multiplied by, let me have a look here at my information sheet, calcium carbonate. Well, calcium is 40.08. Calcium, what is calcium carbonate? It's CaC, so carbon, which will be 12.01, trust me on that, plus 3 oxygens. If we have a look up the mass of oxygen, 16 plus 3 times 16.00. And what do we get when we work that out? Well, that's that number there, so that's going to be multiplied by, open brackets, 40.08 plus 12.01 plus 3 times 16, close that up, equals 0.228 grams. Calculate the percentage of calcium carbonate in the rock sample. So that's how much calcium carbonate. So percentage CaCO3 in rock is equal to 0.228 divided by the original mass, 0.280, which is up here, multiplied by 100, divided by 0.280 equals, multiplied by 100 equals 81.3%. And that's question 23.